Tawan. So my topic today is about the guideline for reserve and resource assessment. My background is reservoir engineer in oil and gas. So I work for Gaffney Klein, is independent consultancy for energy. And aside for my job, I'm also very active with the Society of Petroleum Engineers, and in particular the flow assurance technical section. And I think we also have some topics that are relevant to the geothermal industry, like scaling. In Taiwan, so the Society of Petroleum Engineers is very active also in the geothermal industry. It's providing a lot of research papers, some platforms, there is an event in the UK starting today with a geothermal conference, and we want to help also this industry. So my company, just to describe a little bit, is international energy consultancy, and originally in the 60s it was mainly founded to help the oil and gas industry with third-party reserve and resource assessment. And you will understand later that when we do these assessments, it's looking at the whole project, the whole development of the field, and looking at not only the subsurface, if the resource is there, but also if the project is economic, if the right approvals are there, if the right entitlement is with the operator, and also the facility. So because this is such a multidisciplinary effort with close collaboration of different experts, then these skills and collaboration are also used for different projects, so side projects like we can help with valuation of assets and different services for the industry. So this is the kind of project that we help, the kind of services, and the initial one was independent reserve and resource assessment. And when we do this work, then we are also well placed to do the valuation of the project, to help the government make sure that the project going ahead are good projects that have looked at all the elements in place. So this is my outline for today. I will touch on why it's important to do these reserve and resource assessments, why the industry might want to have them, and why do we need the guidelines for common understanding of the definition of the words that are being used. So I'll describe some guidelines. So the two main ones, spoiler alert, is UNFC and PRMS that have been used already. And both of them, they are project-based, so I will explain why we need to look at the whole project, then give some examples. If a company wants to develop some geothermal project, then they might want to benchmark different opportunities against each other. So internally in the company, you might want to follow some guidelines, some internationally approved language and definition to look at all your project and prioritize your strategy. So this is an internal effort. You do your own evaluation and assessment of the different opportunities. Then in some circumstances, you might want to have a third-party company look at these numbers, either because you want to have comments and insights from a company that is more experienced at just this specific exercise and looking at all the different assets in many different companies and everywhere in the world. Then you will get their assessment and you can compare with your internal view. Or another use also is if you want to divest, so if you want to sell an asset or if you are interested to buy an asset, then you might want to use this service. Maybe if you are divesting your asset, then you can say, oh, this third-party assessment, the people interested, the potential buyers will have higher trust in a third-party assessment. And another use is if the government is requiring this third-party assessment for approval for development. So yeah, it's a quite clear understanding that the definitions need to be very clear for everyone. So there needs to be an international guideline to follow. So in the oil and gas is quite mature industry for these guidelines and for these assessments. Most projects have been assessed many times and over their whole project life. And early 2000s, there were some shocks where some situations where maybe the company misrepresented their project and their portfolio. So it can angry the governments and the investors because maybe the country has made some decisions based on the production profile coming from these companies, and then when the so in this case it's oil and gas company, when the product is not being available, it makes some changes to the situation, and so it can make some embarrassment, and in some cases it can be quite a problem for the contract. So the oil and gas industry went through this exercise, and they understand the need for like a third-party assessment and very clear definitions of what are we talking about, what's the maturity, what's the probability of the volumes we are talking about. So yeah, it's basically what the same saying. Yeah, in both the quantification and also the classification, meaning the maturity of these volumes. It's important to understand what exactly are we talking about, so that we don't get misrepresentation of a project. So these are the some guidelines I will explain. So the Society of Petroleum Engineers has this petroleum resource management system that has been used for many years by the whole industry, and it's a very trusted system. Then specifically to the geothermal industry, there is the International Geothermal Association published the Code for Geothermal Resource and Reserve Reporting, and then following this one, the Australian they issued the kind of first international guideline that was accepted, this Australia code, and then soon afterwards the United Nations also had a push to have a classification framework for looking at the different resources. So it's not only geothermal, it includes all the different resources. So there are some similarities between the UNFC and the SPE-PRMS. I will talk more about these two later. And then some countries publish their own guidelines. There are some more than here, because they want an orderly development of the resources in the country, and they require to see strict assessment of all the elements of the project before giving approval for development. So I only put two, but many countries have these guidelines. So I mentioned before that it is a project-based framework, both the UNFC and the PRMS. So when we talk about reserves, actually it's not only the subsurface that has been assessed. We look at has the subsurface been analyzed in enough detail, and if the volumes are in place. But we also look at if the entitlement is there with the operator, and all the elements of the project, the development plan, if it makes sense, if it's the right dimension and the right development to support the lifetime of the field, and the economics is a fundamental aspect, and also if the approvals are in place for further going forward of this project. Yeah. And then we might think, and what is the right time to do this assessment? So this is the difference between resource and reserve. So when we talk about resource, it's earlier stage. We are looking at maybe exploration phase, or there will be something missing for it to be economic and fully approved project. So the resource, yeah, it's early stage, and it could be discovered or undiscovered. So we have the similar timeline in the geothermal. We are also, before we drill the geothermal well or early stage, we only have some wide range probability of what is the resource in place. And then this wide range should, in theory, narrow the further we go in the life of the project. And once we are in a situation where we have the power plant producing already, and we can see the temperature at the wellhead, how it's evolving, then we start to understand what is the renewal of the heat, and we can give a much finer quantification of the reserves which are present with this project. So the times when you might want this assessment: earlier stage, when you are looking for financing for exploration, then FID, just before a final investment decision, when a lot of maybe the power plant is going to be built, some investors or the government and the local council might want to see an assessment of what exactly this project is using international standards. Or when you want to sell a mature asset is also another time, similar to the oil and gas industry. So this United Nations framework classification, it can be used for all these different type of resources. So in the mining industry, oil and gas, for renewable, like this case, geothermal, uranium, CCS, and this is landfill, and also for water. So it's quite robust. The version that is valid at the moment is the latest one published in 2019. So this is how it looks like. So the quantities that can be associated with the project lifetime, they are classified in these different boxes. So there are 3 dimensions. So this UNFC is, because it can be used for all the resources, it's a little bit more complex than the PRMS. There are 3 dimensions, whereas the PRMS has only 2 dimensions. So the G dimension at the bottom is the probability in the estimates. So in the worst case, which is sorry, not F4, is G4, the product quantity associated with this prospective project estimated primarily on indirect evidence, or maybe there is a hot spring area, or some published paper, but not so much specific work and the data collection associated with this project. Then the more confidence we have, it's associated with more specific data gathered at the site. Like, for instance, if we have a well, then we have much increased confidence in the presence of the heat in place. And later in the production, we even have more information about the renewed rate of the heat. So then it moves from the G4 to G1. The 2 other axes is more on the feasibility and viability. So the F axis is on the project feasibility. So it's maybe more on the technological side. Is the technology available to develop this field? So on the F4, we have no idea. And then when we propose technology and we show the plan of development of what kind of well is going to be used, what completions, what kind of drilling, then we move towards F1. And on the other one is socio-economic viability. We have only 3 categories, the E3, E2, and E1. For the worst case is the development is not environmentally, socially, and economically viable in the foreseeable future, or it hasn't really been analyzed. The situation has not been analyzed. So in this case, yeah, originally we don't know, and then the operator has to work with the local community, it has to work with the government, it has to do environmental assessment, and then if all this work is being done, we move from E3 towards E1. Now I will describe a little bit more about the PRMS, which might seem surprising how this guideline, which is published for petroleum resources, can be used for geothermal, but when you see the table you will understand the analogy. So this is the table, this is the main thing we need to understand about PRMS. Everything is in this table. So there are two dimensions. The category is the probabilistic distribution of the volumes. And the classification is the maturity. So in all cases, you can see there is a 1, 2, and 3. So P90, P50, and P10. P90 means there is probability of more than 90% that the volume in place are more than this number. So in terms of heat, you will say, oh, there is more than 90% that we can extract this heat of this power out of this project. Then P50, more than 50% chance. P10, there is more than 10% chance. So P10 is the high side, is probably is going to be less than this number. Then as the project matures, we move from undiscovered, which is the blue category, is prospective resource. Maybe we haven't drilled a well, we don't know much, we only have some evidence. So the geologist has done some assessment based on what data is available, some analogs nearby, and has some assessment of what can be done there. Then the company has some idea about which technology they want to use, and we have some beginning of the project, beginning ideas. And then as all the different discipline matures, the company is getting their approvals in place with the local council or the government, and also they are getting the entitlement, make sure that they have right to work in this area, do the exploration, do the data gathering, they gather more samples. Then it's moving to contingent resources. At that time, they already have a good idea of what kind of technology they want to use, and what the development looks like. They have more refined definition of a closer range of uncertainty for what's the size of the project, how much megawatt the plant is going to be. And then to move on to reserve, the last is from sub-commercial to commercial. So we need to make sure that the tariff is correct for to cover the cost. So we need to have better assessment of the operating cost and what capex, what capital is going to be needed for this development. So as you can see, it's very applicable to the geothermal projects. And actually, in 2021, the PRMS was used for geothermal projects, and in 2022, the Society of Petroleum Engineers published on their website that actually the PRMS can be used for geothermal projects as well. So yeah, I just have more description about why PRMS might be quite suited. So because the PRMS is used a lot in the oil and gas industry, then all the financiers, all the governments, they are quite familiar with this system, and they understand quite well the definitions. So then when we move to geothermal, this system is quite tried and tested. We already understand how it can support the project and how it can move along with it. Yeah, and then the other comments are based on the similarities between the oil and gas project, which also has some flow in the subsurface. So saying that this PRMS is better suited, that some other systems which are based on the mining. Like initially, I spoke about the International Geothermal Association, and apparently the initial Australian reserve and resource assessment for guidelines for geothermal were more aligned with the categories found in mining. So, So this is about the fact that the whole industry is quite familiar, meaning the regulators, the financiers, and the governments, they are familiar with the system, so they will understand for a geothermal project what is the maturity of the project and what is the probability, because it's following the same as this PRMS. And then, that's what I wanted to get to, is that comparison between, on the right side, we have the system based on the JOG, so the mining reserve and resource classification and guideline. At Gaffney Klein, we believe that it's actually more better suited to use the PMS. It's easier to understand the different, to use the system. And then the UNFC. So there was quite a lot of work done by, in particular, there is this paper by Gioia Falcone. She compared the UNFC and the PMS and found that it mapped together quite well. The different situation. These are 3 examples of use. So the UNFC, as you saw, this current version is 2019. So before publishing it, they did some sessions in different parts of the world, and in these sessions they tested the guideline with real examples, real projects. So these are the 3 examples that were tested at that time. Nowadays the UNFC is actually quite accepted globally, and I think on the government side and the councils, they are quite happy to use this UNFC. It has been used, this is in December last year in New Zealand, and also I think the government of Queensland now mandate the use of UNFC for their project in their region. And then this is Ryder Scott is also independent reserve and resource auditor for the oil and gas, has used the PMS in 2021. So as my summary is basically the shortcut is to say, if you so definitely it's important for benchmarking and good quality of the project and making sure there are no failed projects and scandals going around. Then to use some guidelines with clear definitions. Then if you are on the operator side and looking or financial side, the PMS is quite tried and tested and is quite a good guideline. And then if you are the government and looking at different resources in your country, then the UNFC is quite useful. And then they map between each other, so it's a good environment to move forward. Thank you very much.